There's a new signal.NotifyContext API in the standard library, which is nice because, you know, I mean, signal notify precedes context, I think. So that's why,
Oh,
you know,
okay.
just
Mm.
for anybody who hasn't seen it, this is a sort of a pretty standard pattern for Go servers, isn't it? That you create some channel of
Yeah,
os.signal and you call signal.Notify and say, please notify this channel if you get one of the following signals. OS
yeah.
interrupt, let's say.
Actually,
Um,
yeah, I agree
or
because
or syscall.sigterm, or there's a few different signals you can get, isn't there? And what happens is when the process gets that signal,
mm,
a message will arrive on your channel and you can then decide what to do. So in your case, at line 57 here, you have a channel receive statement, receive from the quit channel, and this will just block until there is some signal, won't it? And
yeah,
then when that
yeah,
happens, you start your shutdown
yeah,
process.
exactly.
So you can now say signal notify context to say, give me a context which will be notified if
Okay,
I get a signal, which is nice, isn't it? Because that's
yeah,
context is the way that we deal with any long-running process that we might need to cancel or time out.
okay, yeah,
So that's really neat. And I think one other thing is I think that channel
yeah.
needs to be
The quick channel.
yeah, the quit channel I think needs to
Yeah.
be buffered.
Yeah, actually, I didn't at the time of writing this code, this piece of code, I didn't quite have a solid grounding on buffering. I really, this is an honest confession. I've dreaded buffered channels ever since I discovered channels on Go.
Right.
I didn't know how to use it.
Yeah, you wouldn't be the first person who feels a bit intimidated by
Yeah,
channels and concurrent programming in general, which, so no need to feel bad. It's hard. You know, there's some
yeah,
super experienced engineers, some of the best people in the world, who find concurrent programming hard because it just is hard. It's difficult to
it
reason
is.
about. Nothing to do with Go. I think Go makes it as easy as it
As
could
it
be
can
made.
get. Yeah,
But I find a really helpful way to think about it is basically there's sort of two things, both of which are called channel. That's slightly
hmm,
misleading. Um, if we think about an unbuffered channel, if we try to send to it, then we just block until someone else is ready to receive, isn't it? So it's
yeah,
almost like a mutex, you know, saying I can't proceed any further until someone else releases me, you know,
yeah,
by receiving, or vice versa. If you're trying to receive, you'll just block until someone else
yeah.
sends.
Sense.
That's very useful if that's the behavior you want. You know, if you want to synchronize two Go routines to say this one mustn't start doing its thing until the other one is ready or something, you could use a mutex, but a channel is a cheaper way of doing that. And that's great. Now there's a totally different thing for a totally
Yeah,
different purpose,
hmm,
which is a buffered channel. And that's
yeah,
exactly the opposite, isn't it? So a buffered channel has some room in it that if you want to send to it, you can. It just gets stashed in the channel and you can move on to do what you want to do. Someone else can come along later and say, I'd like to receive from that channel. Well, here you are. There's something for you. You know, it's like a post box. You know, you can put letters in it and then the person can come along and take them out later. Um, I don't know what the metaphor is for an unbuffered channel, but it's not like that. It's like a
yeah.
post box with no room in it. You just have to wait there until the person arrives and then hand them their mail, you know.
The question I would ask, you know, on that note, using buffer channels is I used to think that you use a buffer channel when you already know beforehand how many things you can wait for, how many things you want to accommodate. Like let's say if you have four Go routines and you are sure they will always be four, then you can have a buffer channel with a capacity of four.
Yeah. Yeah, and that's, you know, sometimes it doesn't really matter exactly what the buffer size is. It's the fact that it's
Okay,
buffered that
okay,
is critical. And just like, you know, if you think about a typical concurrent pattern in Go is maybe, you know, you have a bunch of work to do, you chunk it up
yeah,
into chunks, you start n Go routines, give them each a chunk, and then they send their results back on some channel. When they're done, that's great. that would obviously be a buffered channel in that case, wouldn't it? Because we wouldn't want the workers to sit there blocked, waiting for someone to receive their result. That would just leave CPU on the table.
Yeah,
So
sure.
what we want is to keep all the workers busy at all times and just give them somewhere to dump their partial results until we're ready to process them. So the way I think about it is basically a buffered channel is for concurrency, and an unbuffered channel is when you want to prevent concurrency.
Oh yeah, I agree. That makes sense.
Sounds a bit weird, doesn't it? But that is actually how it works.
Actually, it sounds, that's exactly the mentality I had before. China, I think I understand, but then again, I don't understand.
Yeah. Well, if we think about the signal example, what's really happening here is we're saying to the kernel, if you want to send a signal to this process, please put it into this channel. Now, if that channel is unbuffered and we're not ready to receive from it, someone would have to block, wouldn't they? Who would have to block? The kernel. That makes no sense. We can't block the kernel. So as I understand it, I think if the channel is unbuffered, you just simply won't ever get anything.
Yeah, sure.
It will refuse to send to you because trying to do so would block it. So we need at least one. In fact, at most one, because if we ever get one, then we're shutting down. So we don't need to buffer any more than that.
That actually, that's good that you said that, because I used to think that the only time that this Go routine is gonna receive this OS interrupt signal is when you do a control C on the terminal.
Yeah.
I didn't know that other things like the kernel can interrupt your server.
Yeah.
Now that makes sense, having a buffer channel.
Yeah, and I think also, what's the other signal you can get? Interrupt is Control C, and I think you've also got a sig term if you use kill in Unix. I think it's syscall.sigterm, something like that.
I think so.
Don't know why it's in the syscall package as opposed to OS, but it's probably because it is a syscall.
Yeah.
So we could add that to the list of signal.Notify, couldn't we? We could say notify us about syscall.sigterm as well.
Yeah, sure, we could.
In fact, we'd just pass another argument to signal.Notify, wouldn't we? Because I think it's variadic.
We pass it, right?
Yeah.
Is it a syscall? It's a syscall, right?
Yeah, I think so. Oh yeah.
Syscall.
Try syscall.sigterm. I could be wrong about that.
I think it is. I've used it before.
People would be screaming at the TV.
Yeah, actually, it has. That's one. Okay. Is there any relationship between the OS package interrupt and syscall.sigterm? Are they the same type?
Yeah, it's a syscall.signal, which is just a numeric constant, and I think an OS interrupt is a signal.signal, but it's all good. It's an OS.signal. Yeah, it's all good. One interesting thing is there is a syscall.sigkill, which is kill -9, but you can't ever receive that signal.
Oh, why so? I've never really used it before.
So sometimes I see people, using signal.Notify to sign up for interrupt, term, and kill, and I'm like, you'll never get sig kill because the semantics of sig kill is it just kills you instantly.
Oh yeah. Just like.
Yeah, a term signal asks the process, hey, I'd like you to shut down. Is that convenient for you right now? Get back to me when you're ready to shut down. Whereas kill is like, you're dead, that's it, you're gone.
Yeah.
Which is one reason not to do it, except in emergencies, because the process doesn't have a chance to shut down gracefully. But either way, there's no point registering for it because you won't get it.
Yeah, this makes me question, in particular, a language like Node.js, because I've done it before. I've done servers. I've written servers in Node.js before, but I never ever thought of, handling shutdowns. I mean, you just kill the server and that's it. I mean, like after doing Go, I'm usually not quite okay with not shutting down anything as long as it's a server that I'm writing. Yeah, I just wonder for how folks are using Node.js do their shutdowns.
Yeah.
I'm not really sure how they do it.
Yeah, and I think, oftentimes there just isn't anything useful to do anyway.
Yeah,
If you're being shut down, that's probably it. Um, if you were in a situation where you had critical data in memory which would be lost if you shut down ungracefully, you shouldn't be in that situation. That's risky in itself, isn't it? You might get a sig kill and you won't be able to save it anyway. So,
yeah,
I think that's probably a sticking plaster over a bad architecture. We should try
sure.
and avoid that sort of thing.
Yeah,
So very often you just don't need to worry about it. Don't handle a signal, don't have a shutdown routine, don't cancel context, anything like that. Just crash, just embrace it.
sure.
And in the container world, this makes a lot of sense, doesn't it? Because something
Exactly.
there is something watching to see if your container exits, and it will restart it, or raise, the metrics will show that the container is restarting. It will alert someone if they need to be alerted, and we're in container world, we're just a lot less fussed about all of that operational stuff. It's like Kubernetes kind of does that for us.
Yeah.
So we can just, start, print some stuff to the terminal, and then crash.
Yeah.
So we don't always need to worry about it too much. But you have the machinery here to do it if you need to,
Yeah.
don't you? Which is nice. So when you come along later and say, I need to save state, you'll know where to add that stuff.
Right. Exactly.
So that's nice. So we already found a little bug, not super important, but it's nice to find. And what's really cool about this is how often that happens is when I look at code with people, we end up finding a ton of stuff which is just wrong.
Yeah.
It's not even that it needs refactoring, it's just not what they meant to do. And then they'll say stuff like, I don't understand why I didn't see this. I've been looking at this code day in, day out for weeks. Why didn't I see it until now? And
Yeah.
my answer is basically, well, you weren't really reading it. And that's
Exactly.
and it's completely true, isn't it? When we're working on code, we
Yeah.
don't sit down
Yeah.
and read the entire function from start to finish.
Exactly. Yeah.
We
Yeah.
kind of feel we know what it says,
Yeah. We
but
skim through it.
yeah, we're often wrong about
Yeah.
that. This is
Yeah.
why things like Code Club are also useful, because it teaches people the mental process of sitting down and reading their code like a novel from start to finish.
Yeah. I agree with that.
And you pick up a ton of useful stuff that way, don't you? So let's
Yeah.
continue. Where should we go
Okay.
next?
We should go to. I think we should go to the config.
Yeah,
I want to go through all these dependencies here that are being bootstrapped in the server
yeah,
one by one. Okay, let's go ahead to the config package. So this is the entry point to the config package. This is also a factory function that returns an object that is initialized with all it needs. So you can see I'm using Kelsey's Hightower package to process the environment variables. Well,
yeah.
this is arguable. You could use os.getEnv, but I didn't want to write a bunch of os.getEnv, os.getEnv. I just wanted to
Well,
just make it.
we
Yeah,
love Kelsey.
yeah, we love. Yeah, and I'm a fan of him. Yeah,
Yeah,
so
mad respect to Kelsey, and it's a good library.
yeah, I agree. So here we just loading all the environment variables from the and from the environment, and writing them to the config struct. So I'm basically here I'm setting up the base URL, which we shall see shortly what its purpose is. So after all the processing of the environment variables, we return an initialized config object with all the variables set as
Yeah.
the fields of config struct.
Let me ask
And
you this: so how in love are you with the idea of the config struct? Because I know people who absolutely couldn't do without them, and other people who say they're just not really necessary. What do you think?
actually, I think at the time of doing this, I had weighed in on a couple of ideas, and I usually like having a config. If I usually like to have a config to let other callers know that if you're going to call me, this is what I need for me to work properly. So
Yeah.
that package, it's like a way of package declaring what it needs beforehand. So that's how I see it.
Yeah, I mean, I think I can see how the config struct comes about because you have some, you know, some server object or something which has configuration, port to listen on or whatever, so
Yeah,
usually you have some new whatever it is function, don't you? New server or whatnot. And that takes parameters, maybe the port,
yeah, um,
maybe a couple other things. As you add a few more things, you think, I don't really like this constructor because it takes like 8 things now. Just seems unwieldy. Why don't I just put those things into a struct? And then I can just
yeah,
pass one of them. But then,
yeah.
the,
And actually, yeah,
but
yeah,
very often your constructor is returning some struct, isn't it? A server
yeah,
struct or whatever.
yeah,
And we could actually put those fields right on that. What are we going to
yeah,
do with the config struct? Just store it on that struct, right? So
yeah,
we don't actually need a separate type just for config. It could just be
yeah,
fields on the server. And then you say, yeah, but how do you set those? Because I don't want to export those fields and have people setting them to the wrong values or whatever. In which case, we would like people to go through some validating function that checks you're giving it valid config. And that's fine. And we could use a tool like functional options for
yeah,
that. We
yeah.
could say something like, when you call new, it takes any number of things which are like with port 8080
Okay.
or with debug mode, you know, with base URL, whatever, with HTTP client, that kind of thing. And then that's really nice because then those parameters aren't mandatory. We don't need to
Yeah,
set them all to nil if we're happy with the defaults. And we don't have to have the user get the server struct back and then set all of these fields individually. They can set it all in one function call with these optional options. Um, and that's very nice. And I'm seeing more and more projects adopt this style now. And it means the config struct just goes away or it just becomes
yeah.
internalized so that users don't see it. Um,
Actually, that's something I really look to consider, especially after the session on Code Club that we did about optional parameters
yeah,
and how you can manage them.
right. I mean, one reason for me wanting to do that was I knew that functional options were a thing that existed, but I didn't really know how to do them. I thought I should probably know that, shouldn't I? So even if I decide I don't want to do that, at least I can give an intelligent description of why not. Um,
Yeah,
so I wanted to learn it myself, and the best way to learn any of this stuff is to try and explain it to someone else. So that's what I did, and people can see that video. Um,
yeah,
but essentially, once you get that idea, it's very simple, isn't it? You're just saying, um, rather than me return you a struct and you set some fields on it, you just tell me what you want to set and I'll set it for you.
yeah, yeah. Sure, I agree.
So we probably won't do that refactory now, but it's definitely something you can think about.
I've noted it down.
You say maybe, the config type could go, the config package could go,
Yeah,
and we just turn it into functional options.
yeah, I agree. Given that I actually saw the example that we did in Code Club, and sometimes you need to like have a practical experience with something for you to really appreciate, the workings or the convenience that particular method gives you.
Yeah. Every student that I ever work with, if I ask them tell me something about Go that you don't feel confident about, seems complicated and difficult, you don't understand it. And they'll say the usual things, interfaces, concurrency, all of this kind of thing, channels. And then when I explain it to them in just the right way, that they get the idea, they just say, oh, but that's so simple.
Yeah.
That's nowhere near as difficult as I thought it
Yeah.
was. And it really is, isn't it? It's just, if it seems difficult, it's because basically it hasn't been explained to you in the right words.
Yeah, I agree.
It's not you being dumb, it's just the person that's tried to explain it to you has tried to use some other concept that you didn't know, or, just didn't frame it in a way that makes sense to your brain, which is on them. So when you find the right form of words for each person, it just suddenly clicks, and they go, "Oh yeah, I see now. That's basically rather obvious, isn't it?"
Yeah.
Which is great. So there must be, for everybody out there, there must be tons of those kind of things which they've heard about, seen other people do, not felt confident to do themselves, but if they can get it explained to them in a way that makes sense, and then do it, as you said, just do a toy program that just uses it. Once you've done it once, that's it. It's easy, isn't it?
Yeah,